Hello students, welcome to my YouTube channel. I am Mr. Pascal Omosa. Today I am going to teach the Ostwald process of nitric acid. In the manufacture of nitric acid, the raw materials we need for this process is ammonia gas and air. So the raw materials, we need number one, ammonia gas, and B, we obtain air from the atmosphere, and this ammonia, we obtain it from Ostwald process. This is what we need, these two. I am going to break this process into chambers. Ammonia gas with air is taken to the first chamber, and this chamber is called a purifier. And in the purifier, the waste products or substances that may poison the catalysts that are used in this process are removed. And these substances include carbon dioxide and dust particles. And dust. The mixture of ammonia and air are taken to the next chamber, and I'm calling this chamber the compressor. And in the compressor, this mixture is compressed repeatedly at a pressure of 9 atmospheres, which is suitable for formation of the products. The compressed mixture of ammonia and air is taken to the next chamber, the heat exchanger. And this mixture of ammonia and air is heated at a temperature of 900 degrees Celsius, which is responsible to initiate the process. From the heat exchanger, the hot mixture of ammonia and air is taken to another chamber here, and this is the catalytic chamber. The catalytic chamber. And this chamber in this chamber, the catalyst used is an alloy of platinum, and rhodium. So this catalyst is responsible to catalyze the process, the reaction between ammonia gas. This is the first chamber where a reaction takes place. Ammonia reacts with oxygen in air, oxygen gas to form nitrogen 2 oxide, NO, nitrogen 2 oxide, and water. But also this reaction releases a lot of heat, therefore I write heat here. Ammonia and oxygen reacts in a ratio of 4 to 5, and the products formed are in the ratio of 4 to 6. So this one is nitrogen 2 oxide gas formed in this chamber after ammonia reacts with oxygen gas in presence of the platinum rhodium alloy, which is the catalyst, and water is also formed. But remember, the air supply to this chamber is in large quantities. Therefore, the products, which is nitrogen 4 oxide and excess air, are taken to another chamber. Another chamber here, the cooling chamber. I will call it the condenser, through the heat exchanger. So from this chamber, nitrogen 2 oxide and air. So I write nitrogen 2 oxide and air are taken to this chamber, but through the heat exchanger. So here I will still say nitrogen 2 oxide and air. In this chamber, nitrogen 2 oxide and air are cooled to a temperature of 30 degrees Celsius. In this condition, in this temperature, nitrogen 2 oxide and oxygen in this air react. Therefore, the equation in the condenser is nitrogen 2 oxide gas reacts with oxygen gas to form nitrogen 4 oxide gas. This equation, if I balance it, I'll place a 2 here, and then I also place a 2 here to balance it. So from this chamber, we move to the next chamber, and what is found in this chamber? Nitrogen 4 oxide. Nitrogen 4 oxide is taken to another chamber. Is taken to this chamber here, and in this chamber I'm calling it the absorption chamber. Calling it the absorption chamber. In the absorption chamber, nitrogen 4 oxide and also air, nitrogen 4 oxide and also air that enter this chamber are sprayed with water. And therefore the equation that takes place in this chamber, the first equation in this chamber is nitrogen 4 oxide gas reacts with water to form 2 acids. The first one is nitrous acid, because it's dissolved, it's aqueous, plus nitric acid, aqueous. That means from this chamber, I'm collecting my nitric acid, for doing any of the uses of it. But again, this nitrous acid that is formed in this chamber, in the second equation, the nitrous acid formed HNO2 aqueous reacts with the air that was initially directed to this chamber. And in this equation, nitrous acid now reacts with that air. I say oxygen in that air. And in this, nitrous acid again is oxidized to nitric acid. That means again we collect the nitric acid in this chamber. Thank you for watching my channel, and let's meet in the next lesson.